Hello viewers, in today's session we are going to discuss another important and conceptual problem from limits, and here we are going to find out the right hand limit and the left hand limit of the function f of x, that is equal to sine of greatest integer of x divided by 1 minus greatest integer of x when x tends to 0, right? So here we are going to evaluate the right hand limit and the left hand limit of this function when x approaches to 0, and then we'll see whether the limit of this function it exists or it doesn't exist when x tends to 0. So let us start. So now the notation for the right hand limit is given by limit x tends to 0, and here we put a positive sign and we have f of x. So now we can write limit x tends to 0, and for f of x we can write sine greatest integer of x divided by 1 minus greatest integer of x. Now to evaluate the right hand limit, here we'll substitute x is equal to 0 plus h, where h is a very small quantity, infinitesimally very small quantity, and h is a positive quantity, and it lies between 0 and 1, right? So here we'll take x is equal to 0 plus h, and when x approaches to 0, from the right of x is equal to 0, then h also tends to 0. So here we can now write this limit in terms of h. So we have limit h tends to 0, and we have sine uh, of greatest integer of x. So x can be replaced by 0 plus h, and here we have 1 minus greatest integer of 0 plus h. So here we can now write limit h tends to 0, and we have sine of greatest integer of h divided by 1 minus greatest integer of h. Now see, here we have a greatest integer of h, and h is infinitesimally very small, and it lies between 0 and 1. So here we have the real number line, here we have 0, and here we have 1. So h is very close to 0, and it lies between 0 and 1. So by definition of greatest integer function, the greatest integer of h should be equal to 0, right? Because h is very small quantity, and it lies between 0 and 1. So the greatest integer of h must be equal to 0 by definition of greatest integer function. So here we can now write limit h tends to 0, and we have sine of 0 divided by 1 minus 0. So we can now write here, because this expression is now independent of h, so we can now remove this limit notation. So we have simply sine 0 over 1 minus 0 is 1, and sine 0 is 0, and here we have 1, and this is equal to 0. So the right hand limit of this function when x approaches to 0 is equal to 0, right? So the right hand limit is equal to 0. So let us now find out the left hand limit, and the notation for left hand limit is given by x tends to 0. Here we put a negative sign, and here we have f of x. So now let us take here f of x equal to sine of greatest integer of x divided by 1 minus greatest integer of x. So we have here this expression, right? So here to get the left hand limit, we'll take x is equal to 0 minus h, and when x approaches to 0, from the left of x is equal to 0, then h tends to 0. And remember, h is a positive quantity and it lies between 0 and 1. So now we can write this limit in terms of h. So we have now limit h tends to 0, and here we have sign of greatest integer of 0 minus h, and here we have 1 minus greatest integer of 0 minus h. So now we can write here limit h tends to 0, and we have sign of greatest integer of minus h, and here we have 1 minus greatest integer of minus h, right? Now see, here we have greatest integer of minus h, and from this inequality, if we multiply this inequality throughout by -1, then we have 0, then we have minus h, and then we have minus 1, and the direction of the inequality, it gets reversed. So we can also write this inequality as minus h is greater than minus 1 but less than 0. So we can now see that here we have 0, here we have 1, and here we have minus 1. So negative h is greater than minus 1, but it is less than 0. So it lies between minus 1 and 0. So the greatest integer of negative of h, due to the definition of greatest integer function, is equal to -1, right? So always remember, greatest integer of h is equal to 0, and the greatest integer of negative h is equal to -1. So we have now here a limit h tends to 0, and here we have sign of -1. Greatest integer of minus h is -1, and we have 1 minus minus 1. So now again here this expression, it doesn't contain any h, so we can now omit this limit notation. So we have now sign of -1 divided by 1 plus 1, and from trigonometry we know that sine of minus x is equal to negative of sine x. So here we can now write negative of sine 1, and here we have 1 plus 1 2. So the left hand limit of this function when x approaches to 0 is given by minus half, and we have sine 1. So from this discussion, we can easily conclude that the right hand limit is not equal to the left hand limit, because 0 is not equal to minus half sine 1. So the limit of this function when x approaches to 0, it doesn't exist, because we know that if we have a function, say y is equal to f of x, and the limit of this function, that is f of x, when x approaches to a, it exists only when the right hand limit and the left hand limit are both equal to each other, and the right hand limit and the left hand limit must exist, right? And moreover, they must be equal to each other. So in this case, we have arrived at the conclusion that although the right hand limit and the left hand limit both exist and they are finite, but they are not equal to each other, hence the limit of this function when x approaches to 0, it doesn't exist.